Did you know that there are planets in our solar system that are small planets as well? Well, they differ from normal planets, but they are still considered planets. If you are interested in knowing more about them, watch this video till the very end so you won't miss out on any information. Without further ado, let's get back to the video. A dwarf planet is a small planetary mass object that is in direct orbit of the Sun, smaller than any of the 8 classical planets, but still a world in its own right. The prototypical dwarf planet is Pluto. The interest of dwarf planets to planetary geologists is that they may be geologically active bodies, an expectation that was borne out in 2015 by the Dawn mission to Ceres and the New Horizons mission to Pluto. Astronomers are in general agreement that at least the 9 largest candidates are dwarf planets: Pluto, Eris, Haumea, Makemake, Gongon, Quaoar, Sedna, Ceres, and Orcus. Of these and the 10th largest candidate Celestia, all but Sedna have either been visited by spacecraft, Pluto and Ceres, or have at least one known moon, Pluto, Eris, Haumea, Makemake, Gongon, Quaoar, Orcus, and Celestia, which allows their masses and thus an estimate of their densities to be determined. Mass and density in turn can be fit into geophysical models in an attempt to determine the nature of these worlds. Some astronomers include many smaller bodies as well, but there is no consensus that these are likely to be dwarf planets. The term dwarf planet was coined by planetary scientist Alan Stern as part of a 3-way categorization of planetary mass objects in the solar system: classical planets, dwarf planets, and satellite planets. Dwarf planets were thus conceived of as a category of planets. However, in 2006, the concept was adopted by the International Astronomical Union, IAU, as a category of subplanetary objects, part of a 3-way recategorization of bodies orbiting the Sun: planets, dwarf planets, and small solar system bodies. Thus, Stern and other planetary geologists consider dwarf planets and large satellites to be planets. But since 2006, the IAU, and perhaps the majority of astronomers, have excluded them from the roster of planets. Starting in 1801, astronomers discovered Ceres and other bodies between Mars and Jupiter that for decades were considered to be planets. Between then and around 1851, when the number of planets had reached 23, astronomers started using the word asteroid for the smaller bodies and began to distinguish them as minor planets rather than major planets. With the discovery of Pluto in 1930, most astronomers considered the solar system to have 9 major planets, along with thousands of significantly smaller bodies, asteroids, and comets. For almost 50 years, Pluto was thought to be larger than Mercury, but with the discovery in 1978 of Pluto's moon Charon, it became possible to measure Pluto's mass accurately and to determine that it was much smaller than initial estimates. It was rough 1/20th the mass of Mercury, which made Pluto by far the smallest planet. Although it was still more than 10 times as massive as the largest object in the asteroid belt, Ceres, it had only 1/5 the mass of Earth's moon. Furthermore, having some unusual characteristics, such as large orbital eccentricity and a high orbital inclination, it became evident that it was a different kind of body from any of the other planets. In the 1990s, astronomers began to find objects in the same region of space as Pluto, now known as the Kuiper Belt, and some even farther away. Many of these shared several of Pluto's key orbital characteristics, and Pluto started being seen as the largest member of a new class of objects, the Plutinos. It became clear that either the larger of these bodies would also have to be classified as planets, or Pluto would have to be reclassified, much as Ceres had been reclassified after the discovery of additional asteroids. This led some astronomers to stop referring to Pluto as a planet. Several terms, including subplanet and planetoid, started to be used for the bodies now known as dwarf planets. Astronomers were also confident that more objects as large as Pluto would be discovered, and the number of planets would start growing quickly if Pluto were to remain classified as a planet. Names for large subplanetary bodies include dwarf planet, planetoid, more general term, mesoplanet, narrowly used for sizes between Mercury and Ceres, quasi-planet, and, in the trans-Neptunian region, Plutoid. Dwarf planet, however, was originally coined as a term for the smallest planets, not the largest subplanets, and is still used that way by many planetary astronomers. Alan Stern coined the term dwarf planet, analogous to the term dwarf star, as part of a 3-fold classification of planets, and he and many of his colleagues continue to classify dwarf planets as a class of planets. The IAU decided that dwarf planets are not to be considered planets, but kept Stern's term for them. Other terms for the IAU definition of the largest subplanetary bodies that do not have such conflicting connotations or usage include quasi-planet and the older term planetoid, having the form of a planet. 30. Michael E. Brown stated that planetoid is a perfectly good word that has been used for these bodies for years, and that the use of the term dwarf planet for a non-planet is dumb, but that was motivated by an attempt by the IAU Division II plenary session to reinstate Pluto as a planet in a second resolution. Vesta, the next most massive body in the asteroid belt after Ceres, was once in hydrostatic equilibrium and is roughly spherical, deviating mainly due to massive impacts that formed the Rhea Silvia and Venonea craters after it solidified. Its dimensions are not consistent with it currently being in hydrostatic equilibrium. Triton is more massive than Eris or Pluto, has an equilibrium shape, and is thought to be a captured dwarf planet, likely a member of a binary system, but no longer directly orbits the Sun. Thebe is a captured centaur that, like Vesta, is no longer in hydrostatic equilibrium, but is thought to have been so early in its history due to radiogenic heating. That's it for the video. If you enjoyed it, kindly like the video and subscribe to our channel.